Okay, well today we're going to talk about the rules of definite integrals and be looking at these 5 items here. So first of all, order matters. So we always will, correct order for an integral is to have the lower limit as b and then the upper limit as a. Now if this order is not correct, then basically what you would do is you would take the opposite then from a to b, okay? Now, the value of an integral where the limits are the same, that means you would travel 0 distance. So then for 0 time, then your distance will be 0. Another definition is, let's say you have a constant being multiplied by the function. That is the same as bringing the constant out in front, being multiplied by the integral value of f of x dx. Now again, remember your negative symbol here. So if you have a negative times the function, you could also bring the negative constant out to the front, which would be the opposite of the integral a to b. Or you could also say that would be the integral of b to a of f of x dx. Lovely. Now sum and difference, if you've got an integral where the integrand is a sum of 2 functions, you can separate them and have the integrand of one function plus or minus the integrand of the second function. And additivity, so if I'm adding 2 integrals, then what you can say, but you notice the integrand is the same function, then together from a to c, I have the value of the integral of my function. Now let's apply some of these rules to a couple of problems. Okay, here's our first example. Notice we're given a graph, and we're going to do number 1 together. So when I look at number 1, I look at the lower and upper limit, and I notice that it's from 4 to 4. Well, think about it. If I go from 4 to 4, actually I have no area under the curve. So the answer here would be 0, as per one of the rules on the previous page. Now, I'm going to pause the minute video, and you are going to do problem 2 and 3. Okay, now that you've paused the video, we're going to do 4 together. Now 4, I immediately notice that the order is incorrect because the lower limit should always be at the bottom of the integrand symbol, or the lower, smaller value. So correctly written, this would be the opposite from 1 to 3 of f of t dt. Now I'm going to use my graph to determine what is the area under the curve from 1, so here's 1, 2, 3. 1, 2, 3. Well, we can see this is a triangle, so the answer is going to be negative 1/2 the base times the height. Well, the base is 2, and the height is 2, so half of 4 is negative 2. So the value of that integral would be negative 2. Now let's try some more. Okay, we notice we have the same function, but the problems are getting a little more challenging. I would like you actually to do 5 and 6. Okay, now let's do 7 together. So 7 has a lower limit of 0 to 6. So as you can see, you're going to start here at 0. Let me use a different color. 0, and we're going to go 1, 2, 3, 4, 5, 6. Okay. Now I'm going to break this up. Now because it's absolute value, that means I want the positive y value. So in other words, instead of this function going below the x-axis, I want to consider it when it's above the x-axis. So I'm going to separate this integral into 2 pieces. I'm going to show my work over here. So I'm going to go from 0 to 3 of f of t dt, and then I'm going to add that to the absolute value of 3 to 6 of the outputs of f of t dt. Well, from 0 to 3, we know that we could actually use 2 pieces here. I could see I have a rectangle and I have a triangle. So if I go from 0 to 1 of f of t dt, and then add it to 1 to 3 f of t dt, because those are 2 different geometric shapes. And then also, for the next one, we have a triangle, but actually it's kind of like 2 right triangles, right? So I'm going to have to get a little more space here. So I'm going to add it from the absolute value from 3 to 4 of absolute value f of t dt, and then the absolute value of 4 to 6, absolute value f of t. Sorry, I needed more space here. Now when I do all this algebra, and basically it's a lot of geometry, right? So from 0 to 1, the area of that space is 1 times 2, so that's 2. And then from 1 to 3, I have a triangle. Well, it's 1/2 base times height. Well, base times height is 4, so 1/2 of that is 2. Then I'm going to add it to the absolute value of this first triangle here. Well, it's 1/2 base times height. So the base is 1, the height's a -1. So it would be the absolute value of a -1/2. And then I'm going to add it to this last triangle here, where this has a base of 2 and a height of 1. So it would be absolute value -2 times 1 is -1. So my final answer then is 2 plus 2 is 4, plus 1 is 5, plus half. So the answer would be 5.5. Okay? Now I just did 7. Now I'd like you to do 8. And our last slide, we're going to take a look at these integrals from a little bit different perspective. So you'll notice here, instead of being given a graph, you're given the algebraic representations of 3 integral values. So we know the value of f of x from -2 to 5 is 18. The value of g of x from -2 to 5 is 5. And the value of h of x from -2 to 5 is -11. And last of all, f of x from -2 to 8 is 0. So let's use these facts to be able to simplify these integral expressions. So the first one is the integral from -2 to 5 of f of x plus g of x minus h of x. Well, I'm going to use the ability to separate this into 3 different sums. So I'm going to have from -2 to 5 of f of x dx, because I'm given that value. Then I'm going to add it to the integral from -2 to 5 of g of x. And then I'm going to subtract it from the integral -2 to 5 of h of x dx. I'm sorry, I forgot to write those d of x's. You need to always write that. Now they tell me that the value of f of x from -2 to 5 is 18. And then this value is 5. And then we're subtracting a -11. So when I simplify that expression, the value then is 34. Okay, let's try another one here. Let's look at number 10. So number 10, there's a couple things going on. First of all, I notice that the limits are in the incorrect order. So I'm going to switch those limits, and it will become negative from -2 to 5. And then I also notice there's a coefficient of 4. So I'm going to bring the 4 out in front of the integral symbol. So it's 4 times the value of g of x dx from -2 to 5. Well, we are told that that value is 5, so the value of the entire integral will be -20. Okay, now going on to problem 11. Okay, here we also have 2 pieces to this sum, so I'm going to separate them. So I have from -2 to 5 of g of x dx, and then plus -2 to 5 of the constant 2 dx. And so we're given the value of the first expression, which is 5, and then plus, now remember 2 is a constant. So if you were to graph it, it's a constant at 2, and we're going from -2 to 5, right? So you're finding this area under the curve. So basically what it is it's 2 times the change in value from -2 to 5. Well, the change in value from -2 to 5 is 7, so it's 7 times 2 is 14. So my answer is 19. Okay. Now I'm going to have you do the last one on your own, and then you will see, actually we've got 2. I'm sorry, I thought there was only one more. Let's do 12 together. I'll have you do 13 on your own. So on 12, the order is correct, but on 12 then I'm going to split it up into a difference. So -2 to 5 of f of x dx, and I'm going to subtract it from the value of the integral from -2 to 5 of 6 dx. So again, we're told this value is 18, subtracting, and the difference between -2 to 5, the lower limit to the upper limit, is 7 times 6 is 42. So the value of that expression is -24. And I'm going to let you do 13 on your own and submit your answer. We will go over these and look at these. Now I'm going to be looking at your responses for your homework grade on this assignment.